So, good morning, friends. Today we are going to discuss about the air-controlled hydraulic valve circuit. So, this is the figure for indicating the circuit, and its fluid power systems. Generally, they are classified into three categories. So, if oil is used for operating a system, it is called as a hydraulic system. And if compressed air is used for operating a system, it is called as a pneumatic system. And sometimes both the fluids are used for operating a circuit, and if that is the case, it is called as a hydro pneumatic circuit. That means it is a combination of hydraulic circuit on one hand, and on another hand pneumatic circuit also. So it's a combination of hydraulic and pneumatic circuit. So therefore, they are referred to as hydro-pneumatic circuits, also called as combination circuits. Now, generally, hydraulic circuits are suitable for slow operations, heavy operations, and steady operations. Similarly, pneumatic circuits are suitable for fast operations, light operations, and unsteady operations. So therefore, both the circuits are combined together as a single unit called as a hydropneumatic circuit. So these hydro-pneumatic circuits can be used for fast operations, for steady operations, and also for heavy operations. So each and every circuit is having its own advantages and disadvantages. So for obtaining the advantages and at the same time for removing the disadvantages, so both the circuits are clubbed together as a single unit, and it is referred to as a hydro-pneumatic circuit. So these hydro-pneumatic circuits, they derive advantages of hydraulic as well as pneumatic circuits, and also they are capable of avoiding the disadvantages of hydraulic and pneumatic circuits. So for removing the disadvantages and for obtaining the advantages of both hydraulic and pneumatic circuits, they are combined together as a single unit, and this is referred to as a hydro-pneumatic circuit. So friends, this is the arrangement of one of the hydro-pneumatic circuits. It's called as air-controlled hydraulic valve circuit. Also, it can be referred to as air-controlled hydraulic circuit. That means here hydraulic circuit is arranged on the right hand side of the diagram, right hand side of the arrangement, and pneumatic circuit is arranged in the left hand side of the diagram. So both the circuits put together, that's why it is called as a hydro-pneumatic circuit. So on one hand, you are using the components of a hydraulic circuit. On another hand, you are using the components of pneumatic circuit. So it is a combination of both these circuits. So therefore, it is referred to as a combined circuit or combination circuit. Simply, it can be referred to as a hydro-pneumatic circuit. Friends, now in this circuit, an air valve, that is pneumatic valve, is used for controlling the operation of the hydraulic valve, and the hydraulic valve is used for controlling the operation of a hydraulic cylinder. Ultimately, of course, the hydraulic cylinder is used for operating the tool or a spindle of a machine. So this air valve, a pneumatic valve, is also called as air valve. So we can see the air valve in the left hand side of the diagram, and hydraulic valve on the right hand side of the diagram. So air valve is controlling the hydraulic valve, and ultimately the hydraulic valve is controlling the hydraulic cylinder. So therefore, it is called as air-controlled hydraulic valve circuit. That means air is controlling the hydraulic valve used for operating the hydraulic cylinder. So therefore, it is called as air-controlled hydraulic valve circuit. Simply, it can be also called as air-controlled hydraulic circuit. Now, friends, we can see the arrangement. As I have already told you, we can see the arrangement of hydraulic circuit on the right hand side of the diagram. So here an oil reservoir, a reservoir is placed for storing the required quantity of oil, so which is ultimately used for operating the piston arranged inside the hydraulic cylinder. So this is called as oil reservoir, and we can see the arrangement of pump and motor assembly. So pump is driven by means of a motor. So therefore, the shaft of the pump is connected to the shaft of the motor. So if you switch on the motor, initially the motor will be converting electrical energy into mechanical energy of the shaft. And finally, the pump will be converting mechanical energy of the shaft into pressure energy of oil. So friends, of course, this high pressure oil is ultimately used for operating the piston that is arranged inside the hydraulic cylinder. And now, during the operation, the pump will be continuously in working condition, so it will be sending high pressure oil. So therefore, lot of pressure will be developed inside the system. So if excess pressure is developed in the hydraulic circuit, that excess oil will be flowing into the pressure control valve. So that is shown on the right hand side of the hydraulic circuit. So this valve will be coming into open position. It will be receiving the entire quantity of excess oil that is present in the circuit, and it will be discharging the same quantity of oil into the reservoir. Now, after some time, the pressure will be falling back to the normal value. As soon as the pressure falls back to the normal value, automatically the pressure valve will be coming to closed position. So if excess pressure is developed, is present in the circuit, automatically the pressure valve will be coming to open position, and the pressure falls back to the normal value, automatically the pressure valve will be coming to closed position. So this is the main function of the pressure control valve. So also referred to as a PC valve. Now finally, a direction control valve, that's called as a hydraulic DC valve, is arranged for sending the oil into the hydraulic cylinder in required direction. So this is called as a hydraulic DC valve. So 4 ports are made in this DC valve. So therefore it is called as a 4-way DC valve. The inlet port is connected to the pipeline coming from the hydraulic pump. The first outlet is connected to the first port of the cylinder, and the second outlet is connected to the second port of the cylinder. And finally, the exhaust port of the DC valve is connected to the pipeline that is going back into the reservoir. So totally the valve is having 4 ports. It's having 1 inlet port, 2 outlet ports, 1 exhaust port. So total it is having 4 ports. So therefore it is called as a 4-way hydraulic DC valve. Now this valve will be in, coming to first position. The valve will be placed in first position for moving the piston in forward direction, and the valve will be coming to second position for moving the piston in reverse direction. That means in the first position, the inlet will be in contact with the first outlet, and the second outlet will be in contact with the exhaust port. So therefore, liquid will be entering from the left-hand side of the piston, and it will be leaving from the right-hand side of the piston. So that is used for moving the piston in forward direction. And in the second phase of operation, the valve will be coming to second position. In the second position of the valve, the inlet will be coming in contact with the second outlet, and the first outlet will be coming in contact with the exhaust. So therefore, oil will be entering from the right-hand side of the piston, and it will be leaving from the left-hand side of the piston. So this is used for moving the piston in reverse direction. So friends, the first position of the DC valve, hydraulic DC valve, is used for performing the forward stroke of the piston, and the second position of the DC valve is used for performing the return stroke of the piston. So these are the, various components of the hydraulic circuit arranged in the right-hand side of the arrangement. These are the elements of the circuit shown in the hydraulic circuit shown in the right-hand side of the diagram. And now let us identify the components of the pneumatic circuit placed in the left-hand side of the diagram. So here a compressor is arranged. A compressor is required for operating a pneumatic circuit. So this compressor is driven by another motor. So the shaft of the compressor is connected to the shaft of the motor. So if you switch on the motor will be coming into action. It will be converting electrical energy into mechanical energy of the shaft. And finally, the compressor will be converting mechanical energy of the shaft into pressure energy of air. So that is called as compressed air. Friends, this compressed air, it is ultimately used for operating the element of the hydraulic DC valve. So that's why it is called as a air-controlled hydraulic circuit. And finally, we can see the arrangement of an air valve. So this air valve will be sending air into the DC valve for moving the element of the DC valve in to and fro directions. So this is called as a pneumatic valve, and 4 ports are made in this pneumatic valve also. So is consisting of 1 inlet port, 2 outlet ports, and 1 exhaust port. So therefore, this air valve is also it is having 4 ports. So therefore, it is referred to as a 4-way air valve. Also, it is referred to as a 4-way pneumatic valve. Now, the inlet port of the valve is connected to the pipeline that is coming from the air compressor, and first outlet port is connected to the left hand side of the DC valve, and second outlet is connected to the right hand side of the DC valve, and ultimately the exhaust port is connected to the pipeline that is entering the atmosphere. So just like hydraulic DC valve, so this valve will be also having 2 positions. So just like a DC valve, in the first position, the inlet will be coming in contact with the first outlet, and second outlet will be coming in contact with the exhaust port of the air valve. So therefore, air will be entering from the left hand side of the DC valve, and it will be leaving from the right hand side of the hydraulic DC valve. So therefore, the element of the hydraulic DC valve moves in forward direction, and automatically the valve will be coming to first position. That means when the air valve comes to first position, automatically the hydraulic valve will be also coming to first position, and this is used for moving the piston of the hydraulic cylinder in forward direction. And finally, in the second phase, the air valve will be coming to second position. So in the second position, the inlet will be in contact with a second outlet, and first outlet will be coming in contact with the exhaust port. So therefore, air will be entering from the right hand side of the DC valve, and it will be leaving from the left hand side of the DC valve. So therefore, the element of the hydraulic valve moves in a reverse direction, and therefore, as a result, the valve will be coming to second position, and this is used for operating the piston of the hydraulic cylinder in reverse direction. So friends, this is about the working of this hydro pneumatic circuit. So initially the air valve will be coming to first position. As a result, the oil valve comes to first position. As a result, the piston will begin to move in forward direction. And the second phase of operation, the air valve will be coming to second position. As a result, DC valve, hydraulic valve will be also coming to second position. That is used for moving the piston in reverse direction. So, friends, first position of air valve and hydraulic valve is ultimately used for performing the forward stroke of the piston, and second position of the air valve as well as the hydraulic valve is used for performing the return stroke of the piston. So this is, called as one cycle of operation, and these cycles will repeat continuously so long as the circuit is in working condition. So friends, this is about the construction and working of air controlled hydraulic circuit. And coming to the air valve, finally coming to the air valve, we can see a mechanism that is referred to as a cam mechanism. So this is used for moving the element of the air valve in forward and backward directions. So cam mechanism is used for moving the element in forward direction, and additionally return spring is also used for moving the air valve element in reverse direction. So friends, a mechanism, a cam mechanism, or simply some mechanism is used for operating the element of the air valve. It's called as mechanical actuation. And similarly, compressed air is used for operating the element of a hydraulic valve. So it is referred to as air actuation. So cam mechanism is used, mechanical actuation is used for operating the element of the pneumatic valve, air valve, and similarly air actuation is used for operating the element of the hydraulic valve. So friends, an element is essential, very, very essential, whether it is an air valve or whether it is a hydraulic valve. Some kind of element has to be installed inside the body of the valve, and we have to make arrangements for moving the elements in forward and backward direction. So therefore, we have different methods for actuating, for operating the valve elements. That's called as valve actuation. Different methods are available for doing valve actuation. Mechanism can be used for doing valve actuation. It's called as a mechanical actuation. Air or oil can be used for operating the valve element. So it can be called as a fluid actuation. And in some cases, solenoid is also used for operating the element of a valve. So that is called as a solenoid actuation. So friends, we have different methods for operating the elements of valves in to and fro directions. That's called as a valve actuation. So if a mechanism is used, it's called as mechanical actuation. If air or oil is used, it's called as a fluid actuation. Sometimes solenoid is also used for doing this valve actuation. That is the case, it is called as a solenoid actuation. So friends, we are using two valves here. Air valve is present in the pneumatic circuit placed in the left hand side of the arrangement, and hydraulic valve arranged in the right hand side of the diagram. Hydraulic valve is arranged the hydraulic circuit present in the right hand side of the arrangement. So a mechanism is used in this situation. In this case, a mechanism is used for operating the air valve. So it's called as a mechanical actuation. And the compressed air is used for operating the hydraulic valve. So therefore, that is called as air actuation. So friends, this is the arrangement of this particular circuit. So here air valve is controlling the hydraulic valve. Hydraulic valve is controlling the hydraulic cylinder. Hydraulic cylinder is controlling the tool or the spindle of the machine. So basically air valve is used here. We are using air valve for controlling the operation of the hydraulic valve. So therefore, it is called as a air-controlled hydraulic valve circuit. Also, it is referred to simply, it can be also called as a air-controlled hydraulic circuit. So friends, we have completed the study of construction and working of this arrangement. So let us make a quick review of all the items which we have discussed in this particular section. So friends, we can see we have seen the arrangement of items. The air valve is controlling the hydraulic valve, and finally the hydraulic valve is controlling the hydraulic cylinder. So it is called as air controlled hydraulic circuit. So hydraulic circuit is coming in the right side. So we have, friends, we have seen the components of the hydraulic circuit. We have seen the arrangement of oil reservoirs, arrangement of hydraulic pump, electric motor, pressure control valve, four-way DC valve, and hydraulic cylinder. So all these, items present in the right-hand side of the arrangement put together, it's called as a hydraulic circuit, and the pneumatic circuit is placed in the left hand side of the arrangement, consisting of a compressor driven by another motor, and consisting of four-way air valve. So it's controlling the hydraulic valve. It's called as a pilot valve, and all connections are made, important connections are made in between the various components. So it's consisting of hydraulic circuit on one side and pneumatic circuit on another side. So therefore, friends, it is referred to as a hydro-pneumatic circuit. Also, it can be called as a combination circuit. So let us note down the functions. We have talked about the functions of the various elements. So oil reservoir for storing oil, ultimately used for sending oil into the system, and also for receiving oil that is coming out of the system. motor for driving the pump, and pump for sending oil into the DC valve, DC valve for sending back excess oil into the reservoir. And also we have talked about the DC valve that is used for sending oil into the hydraulic cylinder. So it will be sending oil from one side of the cylinder, and it will be receiving oil from another side of the cylinder. So this all these items very essential for operating the hydraulic circuit that is present on the right hand side of the diagram. And friends, we have talked about the elements of pneumatic circuit. So consisting of a compressor driven by a motor. So compressor will be sending high pressure air into the air valve. The air valve will be sending, high pressure air for moving the element of the DC valve in to and fro directions. It will be sending air from one side of the hydraulic DC valve, and it will be receiving air from the another side of the hydraulic DC valve. So therefore, this is air valve can be ultimately it is used for moving the element of the hydraulic valve in to and fro directions. And finally, we have to note down the difference between these fluids. So it's a hydro-pneumatic system. In the case of a hydraulic system, we are using only oil. Oil is only required for operating the hydraulic circuit, and air is required. Only air is required for operating a pneumatic circuit. But in this case, we are using both the fluids. So therefore, here oil is called as a primary fluid. So it's controlling, it is moving the piston that is arranged inside the hydraulic cylinder. So therefore, oil is called as a primary fluid. And air is compressed air is used for moving the element of the DC valve in to and fro directions. So therefore, this compressed air, it is referred to as a secondary. So friends, any fluid used for operating the piston of the cylinder, that is called as a primary fluid. And a fluid which is used for operating the element of the DC valve, it is called as a secondary fluid. So friends, oil is used ultimately for operating the piston of the hydraulic cylinder. So therefore it is called as a primary fluid. And secondly, air is used for operating the element of the DC valve only. So therefore, this is called as a secondary fluid. So friends, we have to know the meaning of a primary fluid and secondary fluid. Primary fluids meant for moving the elements of cylinders. Secondary fluids used for moving the elements of DC valves. So these are the functions of various elements used in this particular circuit. So friends, we have seen the pipe connections, arrangement of pipelines made in between the various components. So two pipelines for connecting air valve and oil valve. So first pipeline for connecting first outlet of the air valve will with the left hand side of the oil valve, and similarly second pipeline for connecting second outlet of the air valve with the right side of the oil valve. So they are called as a pilot pipelines. So air valve will be sending air from one side of the DC valve, and at the same time it will be receiving air from the another side of the DC valve. So these two pipelines are very essential pilot pipelines, very essential for connecting air valve and hydraulic valve. But also ultimately they are used for conveying this high pressure air in between these two items. And finally, we have talked about system pipelines. System pipelines, two pipelines used for connecting hydraulic valve and hydraulic cylinder. They are called as a system pipelines. So first pipeline for connecting first outlet of the oil valve with the first port of the cylinder, and second pipeline for connecting second outlet of the oil valve with the second port of the cylinder. So these are the major pipelines. So apart from that, we have to use suction and delivery pipelines for arranging the hydraulic circuit. We have to arrange suction and delivery pipelines, and also we have to arrange branch pipeline for conveying excess fluid into the pressure valve, and a return pipeline for conveying excess fluid from the pressure valve into the reservoir, and finally an exhaust pipeline for conveying oil from the DC valve into the reservoir. So friends, these are the various pipelines to be used for operating this circuit. And finally, this slide is used for indicating the ports and positions of air valves and DC valves. So both the valves, as already mentioned, both the valves will be having one inlet port, two outlet ports, and one exhaust port. So totally both the valves will be having 4 ports. So therefore they are referred to as 4-way valves. And friends, both the valves will be having 2 positions. In the first position, the inlet will be coming in contact in both the valves. In the first position, the inlet comes in contact with the first outlet, and second outlet will be coming in contact with the exhaust. So these first position of both the valves are very useful for performing the forward stroke of the piston. Similarly, in the second position, inlet comes in contact with the second outlet, and first outlet will be coming in contact with the exhaust. So therefore, both the valves will be coming to second position, and that is used for moving the piston in reverse direction. So as mentioned earlier, so first position of both the valves very essential for performing forward stroke of the piston. And the second position of these valves, very essential for performing a return stroke of the piston. So this is called as one cycle of operation. And finally, these ports notations are given for indicating these ports. Capital P for indicating the inlet port of the valve, both the DC valve as well as this air valve. So same notations are used for indicating the ports of air valve and hydraulic valve. So capital P for indicating the inlet port of the valve, capital A for indicating the first outlet port of the valve, and capital B for indicating the second outlet of the valve, and finally letter T is used for indicating the exhaust port of the valve. So these are the positions and these are the ports. We have to remember the notations used for indicating the various ports of hydraulic and pneumatic valves. And finally, friends, we have talked about the valve actuation also. So here cam mechanism is used for moving the element of the air valve. So it is called as cam actuation. The high pressure air coming out of the air valve that is used for moving the element of the oil valve. So therefore it is called as air actuation. And finally, the air valve is controlling the operation of the hydraulic valve. So therefore, it is referred to as air-controlled hydraulic valve circuit. Simply, it can be called as air-controlled hydraulic circuit. So friends, with this, we are going to end this session. So I thank you all for watching this session. Thank you so much.